Hello everyone, I am Amandeep Kaur, Math Mistress from Government Girls Senior Secondary Smart School Nehru Garden. I am participating in the Teacher Fest and my topic is application of mathematics. We all have a question that whatever we study in maths, is it anywhere usable? So students also feel that there is no use of maths, but no, everywhere it is used. So I am giving you few examples where the mathematics concepts and the terms which we have learned and the terms which we have used as a formula, they are basically generated from the daily life things. So let's proceed with the application. Basically we start everywhere with the number system. Whatever we write, like we write 1 over 2. So it is 0.5. That comes under the number system with the base 10. That is decimal number system which we used in our daily life generally in all classes of mathematics. Next is the binary system. All the computers, all the digital medias, mobile phones, anything, each and every coding anywhere in the digital media is done with the taking the number with the base as 2. So basically the number system has been categorized into 4 categories: decimal, binary, octagonal, octal, then base 8 and hexadecimal, that is base number 16. So from these decimal system and binary system, this we very well know. So this is one of the application of maths, that maths without mathematics the generation of computers or internet would not have been possible. So next, another is real life examples of AP. We all know what is AP and what is the rule. Here we have to consider the common difference, the specified rule. Now there are many monuments and buildings which have built on this concept. Rather I can say that from that buildings we generated a formula which we now call it as an AP. So one of such building is the pyramids of Mexico. So you can here see that it is like building with every time the blocks are increasing. This type of building, this type of figure, you have seen it very closely since childhood. So from this building, if I say that the first 2 blocks are 2, then I have again added 2 blocks. I am seeing one side view of the building. So it is first block is 2, then the number of blocks on the next step is 4, on the next step it is 6 and then similarly 8, so on. So this is surely an AP with the first term as 2 and common difference as 2. 4 minus 2, 6 minus 4, so it is 2. So what we have, this is the AP in games. So you have played the game of blocks, building houses. So this is game of blocks, this is on the concept of AP only. Similarly, you might have drawn this hut or the content with cards. This is the first triangle. In first row it is 1 triangle, in second row it is 3 triangle, and in the next corresponding row it is 5 triangles, and then so on. This causes a symmetry. So first is 1, 3, 5. So 1, 3, 5, so on. They are going with the specified rule. Difference is 2. So they are in AP. Clear? Next, trigonometry in aviation and space. We go by the flight. Now at what angle is to land and what should be the angle of elevation? This is the angle of descent and angle of takeoff when the plane is taken off. So that is based on the trigonometry. Even the space shuttles, whatever satellites are launched from the earth, they are set up in their orbit using the concept of trigonometry, the concept of angles and the triangles which are formed there. The sextant, this you might have seen very well. You have seen the bridges, and from the bridges there are the mechanical engineers or the engineers involved there, whatever engineer, civil or mechanical. So they used this I say sextant to measure the slope as well as the height. So at what point there should be the bending of the road and the flyover, so that there is no accidents. So this is again it is using the concept of differentiation also, trigonometry plus differentiation. So tan theta, that is in the trigonometry, is basically the slope. So here this is another application of mathematics. Mathematics and beauty, the nature around us, beautiful flowers we see. So how are they look, why they look so beautiful? Because they follow golden ratio. What is golden ratio? It is a ratio, if we take a length, we can say a thread of two lengths and join each other, A and B. A is the bigger one, B is the smaller one, and if we take the ratio of the bigger over the bigger one over the smaller one, and then the total length over the bigger length, then that ratio is called phi. This symbol, golden ratio symbol, is called phi. If we take it, divide कर दो इसको, A over A plus B over A equals to A over B. So this A over B is phi, B over A will be 1 over phi. So we get a quadratic equation from this. So here phi is 1 plus root 5 over 2, which on calculation is approximately 1.61. That is the golden ratio. Now how it came into existence? This is again linked with the computer also. We are using a SCI codes for that and Fibonacci series in computer. So the concept of the golden spiral is used there also. So what we are doing is 21, we take a square of 21, then 13, then 8, then 5, then 3, and so on. So and this becomes a golden spiral. Right? So this type of figure is seen in many of this type of structure exists in many figures, many structures in nature. So these are some of the examples. So you can study from, you can have a look from the internet also, you will find number of things. Next, application of matrices. We use matrices in the biometric. We mark the attendance, put our finger, and then if our fingers are then recorded, even in the Aadhaar card numbers, we just put the thumb and all our content, all our identification is there. So what is the concept behind that biometric? It is quantization of matrix, quantized matrix 50, quantized matrix 80 or 60, whatever. So here we are using the concept of matrices. So there are so many contents, so many applications where maths is used. So nothing what is learned here is lost. It is used everywhere in some concept. Like we don't even get to know that how it is made. Like we are using phones, we are using internet, but internet would not have been possible without trigonometry. Computer would not have been possible without the binary system. So everything is interlinked and everything is dependent on the mathematics. So I hope I have provided justice to my course, I will say, to my video, to my model, digital model of the applications of mathematics. Thank you.